Since the beginning of time, there has been a war amongst programmers, and this is the war of dynamic versus static typing. Some examples of languages with static typing include Haskell, C, and Rust. These languages require the programmer to predetermine the type of arguments, return values, and so on for their programs. This has the advantage of improved performance, as well as being able to, in most of these languages, catch errors ahead of time to avoid type errors during runtime. Examples of dynamic languages include Python, Ruby, and JavaScript. These languages instead determined to optimize for easy development and quick debugging, as well as prototyping, in return for a slightly slower performance in most cases, as well as a chance at making type errors at runtime, which will then be handled there, rather than at compile time with a statically typed language. Now, we could discuss for hours on which is better for what and what is worse for other things, but I think it's best that we just accept that they all have their own pros and cons, as well as having their own use cases. Now, recently there has been quite a big turn away from things like Python and Ruby, which are purely dynamic, towards a type checker, such as MyPy with Python, and with JavaScript they have TypeScript, which is basically a typed version of JavaScript. Some consider this to be the best of both worlds, where they get a dynamically typed language for quicker development while still being able to implement types in order to prevent runtime errors, but those errors can still occur because deep down under the hood, the language is still a dynamic language. And that isn't saying that all statically typed languages can't have runtime type errors. Those happen sometimes with C and other languages, but languages like Haskell, ML, and Rust are pretty geared towards avoiding these type errors at runtime, so that's kind of a big distinction I figure I should mention. Now, this rise in the popularity of statically typed languages has caused Common Lisp to receive a lot of criticism in the fact that it is a dynamically typed language. Now, what if I told you that's not the whole story? And in fact, Common Lisp also supports statically typing certain sections of code, as well as being able to catch type errors at compile time. In fact, Common Lisp actually supports a very powerful type system that allows the users to create types that are very similar to something you'd see in Haskell or ML, while still being able to use the dynamic typing for quicker development. And in addition, it allows them to create restricted types such that their code can be much more safe and prevent errors that you would see in languages like C that don't really have a very powerful type system. Does that mean that Common Lisp is the best of both worlds? Well, let's dig into that and let's just see how great it is and what possibilities it offers us at compile time type checking and how powerful this type system truly is. Now, just a quick disclaimer I figure I should mention is that while Common Lisp does have this really powerful type system, the actual specification for Common Lisp did not restrict how implementations will use this type system, so your implementation may actually not take advantage of this type system the same way I'll be showing in this video. And so that's why I recommend, if you guys are interested in this, take a look at SBCL or Steelbank Common Lisp. It's the best implementation when it comes to taking advantage of the type system in the ways that I'll be showing in this video. I'll put a link down in the description where you guys can go ahead and grab SBCL. If you guys are on Linux, you can just get it from your package manager. Basically just look around and you guys will come across some way to install it on your operating system. If you don't really know how to do it, you can take a look at Portacle, which is an IDE which actually comes with SBCL, so you can just download the IDE, launch it, and you will have all of the stuff that I'll be showing off this video available to you right out of the gate. So right here I just have a buffer for writing Common Lisp code, so we could do def low. So right here, I just have a buffer where I can write Common Lisp code, and I can hit Control-C, and that will be compiled, and then I can use that in the REPL, just doing hello. There we go. So that's how I'll be doing this today. I'm using Sly, and like I described before, you could use Portacle, and you'll be able to do basically all the same stuff with the same keys that I'm pressing, as you can see down here. If you guys have any questions about this, feel free to throw them down in the comments, and I'd be happy to help you guys out getting this set up. Now let's make our first type error as a result of using a dynamically typed language. So first we will want to do defun. Let's make a function called adder, and it will take A and B, and then we will add A and B. Pretty straightforward. Control-C to compile it. You'll notice we get some like notes basically just saying like, hey, we can't optimize this, just so you know, because we don't know if this is going to be maybe an integer or a float or anything like that. It's not really a big deal, but you'll notice that we get less of these sort of errors as we go, and we'll cover how you guys can limit what it will be expecting, which could be helpful in the future. So we've got adder here. Now let's make a function that uses it. So we're going to do defun, and we'll give it a 2 and a string hello. Now, if we compile that, we won't get any errors. But if we did use-adder and ran that, we will get a error, because basically hello is not of type number, right? As you'd expect. So this is going to be a runtime error because we had to actually run the adder function in order to use it. Now we can actually prevent this error very easily. Now something that you will want to do in order to take advantage of this is actually add a little declaim. So basically you will use declaim, and then we're going to do optimize speed. Let's get speed up to 3 and safety at 3. Now, once again, this is just for SBCL. And so this is just making sure that we are taking the biggest advantage of the safety as well as the speed. And this should allow SBCL to better optimize our code. Now, note we'll still get those notes as an error before, but now we can restrict it. So what we're going to use is another declaim, and declaim is basically hints to the compiler. Now, really quickly, I just wanted to show off actually a way that this is usually checked at runtime. So in a lot of languages, you would actually check the types at runtime. So here we could do check, and then we will do a number, and B is also a number. Now, in this case, as you guys saw before, this didn't really help because we're still going to get the error, but this could be useful for stuff like if you're writing a library where maybe a Lisp implementation won't actually support type checking, this could be useful. Now, what we'll do instead is we'll actually get this to give us an error at compile time, which is much more useful, and you'll see this in a lot of languages. And so this will be done using declaim, like we did before. Now, instead of optimize, we will use FTYPE. And so this tells it that we are defining a function type. Now we're going to do function, and that is just the type of something. And then we're going to define the arguments. Now you can see this little pop-up here is just describing that we are going to define the type of the arguments. Now, as you can see, the type of adder, we would need a number, and then we can give it the return type. That's what that's saying right here, result. And the return type will also be a number. All right. And then finally, we just need to give it the function name, which will be adder. And there we go. And so now when we compile that and compile this again, we still get the type error, the notes telling us about the optimization. But now if we compile this again, we will actually get a compile time error. This is super helpful. And so this will say deleting unreachable code, and it will give us a warning saying that the hello conflicts with the asserted type of number. And if you guys are using Sly, you can use meta n and meta p to kind of jump to these errors and see what they are referring to. Now, just to go a bit more into detail, this is basically what declaim is doing. So we are basically defining the function type of the function given these arguments. So an argument of a number, the second argument is also a number, and then the return value. And then finally, we give it the function name. Pretty straightforward. If you guys have any questions about that, once again, feel free to ask me. Now, if you guys don't like this notation, don't worry. There's actually quite a few libraries out there which are meant to simplify things. For example, there is a library that allows you to do something like this, where you give it an arrow and then you give it like number, I believe, and then the return type, which would be number, and then you just give that right above the function definition, and that will kind of save you some effort. That's very similar to how things look in Haskell, so if that interests you guys could take a look at that. I'll try and remember to link the library down below for those of you guys that are interested. Now, really quickly, let's just go over some of the basic types that you'll be dealing with. Type P is what you can use to basically create a predicate and basically say, like, is this object or variable or anything of this type? So for example, 1 is a type of number. True is a string. Nil as in false. So there you go. So that's how you guys can kind of create a simple predicate. So let's just go ahead and use 1 as a quick example. So is 1 a number, like we just showed? Yes. Now there is a type of T, and T basically applies to everything. So if we gave it a string, then it will also be true. If we gave it maybe, we gave it a list, it will also say true. So T is kind of the type that every other type falls under. So if you just wanted to say, like, for example, you didn't know what the return type would be, you could just set that return type to T. So there we go. So that might be kind of helpful if you guys wanted just some of the type checking, but not the full type checking that you'd be expecting. Now, some other useful types to know about are, so let's go back to 1. So there is also null. And so this is basically the type of nil. So if you ever wanted to check the type of something to be nil, you would use the type of null. A little strange, but once you've seen it a couple times, it's pretty straightforward. Another one is the type of an array, and then we would give it 3. That's an array. It will obviously not work for a list, but if you wanted something that applied to both an array and a list, then you would use sequence, and then there you go, that's true. And then if we gave it an array as well, that is also true. And a sequence is something that you'll see a lot in Common Lisp, but we won't really go too far into sequences. We'll go over that in a future video. Now, another thing that you can do is you can check if something is a list or a cons. So if I did cons, let's turn this back into a list, and hit enter, we will get true. Now, if we actually turned this to nil, we will get false. Now, if we did the same thing with list, which is also a type, we'll get true. But if we did that with nil, we would get true as well. And that's mostly just because if we actually evaluated the empty list, we will see that the empty list is equivalent to nil. So that's why a nil can be used as a list. When you want to check if something is an actual list, we would use cons. We can talk about defining types, which can also be useful for this too. Now, a type that you'll see quite often people using is the type of a fixed num. And so a fixed num is basically, let's just delete all of this. A fixed num is basically what you'd see as an integer in other languages. So let's see, like 200, and then 1. You'll see that it is nil. Anyways, in case that went over your guys' head, this is basically the types that you guys can expect to see. There we go. So once again, T is for everything, null is for nil, strings are strings, arrays, cons is for a list without including null, list is for a list that includes null, numbers basically applies to like everything. So when we did this guy, we could see if it is a number, and there we go, it's true. But so often you want fixed nums, which basically act as an int or an integer in most other languages. Fixed nums are very performant, so it's recommended that you guys use fixed nums as much as you possibly can. Now, this ability to declare functions is not restricted only to being able to use them for functions. You can actually declare the type of a parameter or a variable. So for example, if we wanted to describe a variable, so we could do def parameter, which is basically a way, def parameter is a little confusing, but def parameter basically defines a variable that we can define multiple times. So we did a is 10, and we just, just compile that, and we do a, see that it's 10, and then if we just compiled it again to 20, did a, we would see that a is 20. Just set it to 10. And so while this is useful, it's sometimes helpful to make sure that we're not changing the type of things, because if we changed a to hello, we're not really going to get an error, but often our code might be relying on this global variable to not be changing. So what we can do is we can actually use that declaim from before, and instead of using ftype like we did last time, we would instead use type. Now, type here can be used to define the type, so we'll define a as a number. All right, and so a is a number, and then we're just going to save that, compile that, and then compile this, and we get an error. Now, if we go ahead and change this to the value of 1, we see that that compiles perfectly fine. And then if we did change that to a string, it would cause an error. So that's pretty powerful. And obviously, as you guys can expect, this is really useful for making sure that your code is not changing from underneath you. Now, since Common Lisp is a dynamically typed language by default, it can be helpful to create functions that allow us to pass something like, say, for example, we wanted to give it a number, or maybe make it nil, or like a nullable value. This is not exactly helpful all the time, but sometimes this can be useful. Maybe say we wanted to make a function that took a number or a string or something like that. That could be pretty helpful. So let's go ahead and define something like that. So we'll do def1, and we will define new adder, and we'll take an a and a b. And so what it'll do is it'll add a and b. Now we want to allow for b to be nil. That's just kind of what I'm trying out. So if we want to do that, we could use or to do, so let's say 10. So if we said or 1, 0, then we'll return 1. But if we actually gave it a nil here, then it would return 0. So or can kind of be used as a quick way to say, if this is set to nil, return something else. So let's go ahead and do or 0. Now this is pretty useful, but as you could probably guess, this is pretty restrictive in how easily we'll be able to catch errors ahead of time. So what we can do is we can do declaim ftype like we did before, function, and then we got to give it the arguments. Now it's going to have a number And then we could do number, but the whole point of this was to allow for b to be nil. So instead what we'll do is we'll do or null number. So we're allowing for the type to be a number or nil, which can be pretty helpful. That allows us to do what we were just saying before. Now, obviously we need to give it the return value, which should also be a number. And then finally, we need to give it the name, which will be new adder. All right, now that's pretty helpful. We can define that and redefine that. Now let's create a simple test for that. Now here I have just made a simple test function. Now let's compile that, and we will get a type error due to hello not matching the type signature of number or null. Now if we change that to nil, we don't get a type error, or if we change that to 0, we do not get a type error, and it evaluates as you would expect. Test new adder, there we go. Change that to nil, and compile that, run that again, and it functions the same way, because basically if it's nil, it's being replaced with a 0. So that's pretty helpful. I'm sure you guys could kind of see the value here in being able to maybe accept an array or a list would be a pretty good example of it. There's a lot of different ways you can apply this to take advantage of this type system. Now, while this can be really helpful to catch simple things like passing a string instead of a number, it's often helpful to actually restrict your types even more to a certain subset that you'll need. A good example of this is time, such as seconds. So let's define a new type known as seconds. Now, the way we do this is we define a predicate, which is basically something that will return a true or false value. So we'll do defun seconds -p. So this will be seconds predicate. You'll notice this a lot. For example, the type p was making a predicate to determine if something is a type of something else. Seconds p will take a seconds. This is like going to be really simple. We'll just do less than or equal to, and then we'll do 0, SD9. So S is between 0 and 59, because obviously if it's over 59, it's now a minute. For example, like 60 seconds would be a minute. So that's kind of a good test there. So now we've created that predicate, and now we can do def type, and we're going to call it seconds. It won't take an argument because we don't really need that. And then in quotes, you're going to want to quote this with a single quote at the start, and we're going to do and fix num, because it should only really be an integer. We don't need decimals of a second. I don't believe it. I think that's overkill. And then we can go ahead and do satisfies, and then seconds. There we go. And there we go. So now we have defined the type of seconds. Now the reason I did the and here was basically just to fail early if we gave it the wrong kind of type, as well as some implementations don't actually support satisfies, which is kind of a shame because satisfies is so powerful. It allows you to create a type using a predicate. Now, obviously, this is a simple example, but we could actually take advantage of this. Say, for example, we have parameter a, and then we're going to give it a number of seconds. Let's do 20. Now, you could do a declaim here. Another thing you could actually do is use a keyword, which is the seconds 20. Now this will act one time. It's not going to apply to A, but as you can see, we don't get an error. But if we did 60, let's do 70 and compile that, we will get a type error. Now, obviously this is happening in this case at runtime. Depending on your implementation, it may actually implement this at runtime. I mean, at compile time. But if we wanted to restrict it forever, then we would use declaim. Now, seconds is a really simple example, but we could actually take much better advantage of this for things like a URL. Now, seconds is a very simple example, but a better example would be something like a URL, where strings themselves are quite useful and we pass strings around a lot, but strings also can very easily get mixed up in our code and can result in an undetermined sort of layout of the string. For example, having white space at the start of the end. So it's often really helpful to create a type for a certain string that you'll be using. Now let's go ahead and define a predicate for URL. Now, just to save you guys some time, I actually just defined URL-p, so the URL predicate. This is like a really naive way of checking, but basically it's just taking the first 4 characters from the URL string and checking to make sure that they match HTTP. A better example would be to do this via regex, but I won't make you guys sit through that explanation and that setup, but this is just a really simple example, so it doesn't really matter. And then we can def type URL, and so it's going to be a string, spies URL-p, and let's compile that, and now let's create something. So for example, def parameter link, and then this will be URL link. Okay, now let's compile that. Now that passes just fine. Now if we did this, but instead we changed it, so let's go ahead and do PS, compile that, we will get an error because it cannot determine if this is the type of URL as you guys would expect. So this is a really good example of how you guys can catch these errors at compile time and ensure that nothing's really getting messed up. Maybe say there was a space at the beginning, we will get the same error. Now, obviously, like I said before, using regex is a much better way to do this. Obviously, there are pros and cons to the simpler approach, which is maybe it will perform a lot faster, would be a really simple example. And you guys can make these predicates all over the place, and it kind of allows you guys to make a much more restrictive program to restrict the chances of creating an error, while still during early development, you don't need to implement these types and you can kind of just get away with what you have. Now, there is a library, Radiance, that I will link down below that actually implements a bunch of different types for things like this, like a URL or a URI or anything like that. And so it allows you to take better advantage of this stuff and get a much more restrictive result, which can be a lot more powerful than obviously naive approach that I showed in this video. Now, something worth covering would have been Common Lisp's Common Lisp object system, also known as CLHS. If you guys are Lispers yourselves, you've probably heard of this or seen or know about it already, but it offers things like def method, which allows you to get polymorphism, as well as offering an object system, which is kind of considered to be a sort of subset of the type system. And as a result, you can kind of take advantage of types and objects interchangeably. So that's really powerful, but obviously that goes a bit outside of the scope for this video, so I won't be covering it. Maybe in a future video, if that interests you guys, I'll get into it. Now, I hope this topic and video interested a lot of you guys. I didn't go too in depth with some of the topics. Some topics that I would have really liked to cover was polymorphism, with the CLHS system, as well as the many libraries that implement polymorphism via functions. But those sort of things aren't really worthy of adding to this video because it would definitely extend the runtime. And this is meant to mostly just introduce you guys to the concept of how the type system works, as well as show you just how powerful it can be. Now, in the end, was this the best of both worlds? Well, kind of. I'd say it's a lot better than what you'd see with TypeScript, which is basically a compiler which has to transpile and everything like that, whereas this is actually built into the language. And since Lisp is quite flexible, this allows you to get some really interesting use cases, which I couldn't cover in this video, but a good example of this would be the library def star, which allows you to basically replace defun with this function def star, which allows you to basically put those type signatures in your function declaration, which can be really powerful, and you still get that compile time type checking that you would expect. Will my mind change around this topic? Probably quite a bit. I'll probably say all different kinds of opinions on it in the future, but this is how I feel about it right now. Now, finally, I'd love to give a big shout out to Platinus, Tall Guy Jenks, DFDX, and Car for supporting me on GitHub sponsors. I really appreciate it. Thanks you guys so much. And finally, my solo supporter on Patreon, Connor G. I really appreciate your support. Thanks to all of you guys. I really appreciate it. Can't thank you guys enough. And this has kind of kept me motivated to keep these videos coming, as you guys can see. Thanks everybody for coming, watching this video. I hope you guys learned a bit, and I'd love to hear your guys' thoughts on this approach to type checking, as well as the approach of the type system that it takes. Anyways, guys, I'll see you next time. Talk to you later. Bye.